All right, folks, hello and good evening. Hope you can hear me well. Those of you who are here, just don't forget to sign in the Google Doc. We got about 5 minutes until we'll officially get started. A little less than that, actually, just about 4 minutes. But this is Mr. Droza. I'm here for the Chapter 4 webinar, questions and answers regarding Chapter 4. If you haven't already, you should open up the Google Doc where you can ask questions, and you can even start typing them in before we get started here. So I see we have about 5 students or so are signed into the Google Doc, or they're at least logged. They have the Google Doc open. But if you can hear me now, please sign in. Just indicate if you're here, and if you can hear me, please give me a yes. I am using a different microphone this time, so I just want to make sure that the audio is clear before we get started. But just don't forget to sign into the Google Doc. If you need to find the Google Doc, it's under the posting on Google Classroom. And we'll just wait another couple minutes for everyone to arrive. We got about another 3 minutes. It'll be 7:45. I'm going to give a brief presentation. You can see the front of the PowerPoint right now. It says Chapter 4 webinar. I'll just talk for about 5 minutes, and then I'll take your questions on Chapter 4. Hopefully you've prepared and studied a bit so you have some questions to ask. And if not, I can just give you a couple tips and reminders, and then we'll sign out for the night. Okay, but just please, if you can indicate on the Google Doc if you're here, if you can hear me, that would be great. Be very helpful. So far I see several people have logged in, but not able to hear me, or people aren't writing yes or no. If you can indicate yes or no, whether you can hear me or not, that would be helpful. Thank you, Alice. Okay, Alice says yes, she can hear me. Alex is here with an hola. Hola, señor. ¿Cómo está? Hopefully you are ready for some calculus. Esta noche, tonight. All right, we'll just another minute or so, we'll get started. But please, 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 I see about 5 people have said they're here, but only one person has said they can hear me. So you should have the YouTube live stream open. You can find that on the Google Classroom post. And then just give me a yes if you can hear me. And then we will get started in just about a minute. Feel free to use, headphones or turn up the volume, whatever appropriate, so that you can hear me. I see not everyone has found the live feed yet, so we're going to wait another minute, and then we will get started. Thank you to everyone who was able to join. Okay, so Eric, you can hear as well. That's great. Eric and Alice are already in. And if you're in and you can hear me, you can go ahead and start typing questions in the Google Doc. Feel free to type during my presentation. It's going to be short this time, just about 5 minutes, and then we're going to go right to your questions and try to clear anything up either from the study guide or from the packets, any questions you might have. But I have 7:44 on my clock here, so we're just going to wait. All right, Kayla, yes, thank you for the yes. You can hear me. So we have 3 people who have definitely found the live stream, and we're waiting for some others to find it. 4 people now, looks like I found the live stream. So we're just going to get started in about a minute. Welcome. Welcome. I see Gary has joined us. Ryan with another hello in Espanol. Hola, Ryan. But several people have signed into the Google Doc, but they need to find the live stream so that they can hear what's going on, so this could be more useful to them. So if you're able to communicate with any of these people, that would be great. But I'm just going to put a note on the Google Doc under part 2. Just start typing questions whenever you are ready. Should see Chapter 4 webinar. Welcome if you just joined us, Chapter 4 webinar. Okay, great. Andrew can hear me. Gary is here. And so I have Gary, Eric, Kayla, Alice, and Andrew are all able to view the live stream. We have some others who are in the Google Doc, can't quite see the live stream yet. Hopefully they know it's a separate link. Maybe if you can let them know that. If you're friends with anyone who has not been able to find it, just text them so they can see. Okay, Ryan is in. Great. Ryan can hear the audio. And we're just waiting for a few more people. But it is 7:46. So I'm going to go ahead and get started, and we'll let those other people find their way along. I will be posting the entire PowerPoint afterwards, so you can see that. It's going to be short, and I'll also post a replay of this webinar for anyone who wasn't able to watch it. All right, so welcome. Thank you so much for joining us for Chapter 4 webinar and questions. A couple reminders. Here's the first slide here. Let me just make sure I have this open. Oh, I lost my screen sharing. One moment. Okay, here we are, Chapter 4 webinar. So just a reminder on the format tomorrow. You know, it's a quiz, so not as much material as a test. It's just those 4 sections, but it is going to be 5 multiple choice. Those are AP style, 3 open-ended questions, and there is no calculator. You do want to work efficiently to make sure you have as much time as needed for harder questions. So, I mean, my advice is always do the stuff you know first. If you hit a roadblock, circle it and head back to it later. You don't want to waste like 5 to 7 minutes early in the test and get stumped on something because you're not going to get that time back. So my advice is do what you know. As long as you're in a groove, you're making progress, keep working on that question. But if you hit a roadblock, you get stuck, save it for later. Derivative rules to know. You have to know how to do implicit differentiation. Inverse trig derivatives, you have to know f inverse prime of x. There's a formula for that. You got to know your logarithmic derivatives as well as your exponential derivatives. So those are just a bunch of rules and ways of differentiating that you need to know. Don't forget about that pro tip for implicit. Those of you who were there for the pro tip, we saw that once you differentiate, if you're doing it at a point, for example, finding the tangent line at a point and you're differentiating implicitly, once you differentiate implicitly, you don't have to do that extra step in algebra of solving for y prime. You actually can plug in the x and y right into that step, and it's going to save you some time. So feel free. That's an option to you, and it is a pro tip. If it's at a point, that's going to help you be quick. A couple note on simplifying derivatives. So you do technically have to rationalize denominators. You should not have negative exponents, and if possible, you want to factor out all common factors. So just make sure you can do that, and then you'll have the derivative simplify. But the main goal is differentiating correctly. Okay, so the first and foremost, you want to differentiate correctly. Don't waste a lot of time on the simplifying piece. It's more important to get the derivative right and then simplify and then simplify. I mean, worst comes to worst, you might lose a point out of a 5-point question because you forgot to factor out a common factor. But first and foremost, get the differentiation correct. And then you can simplify it. We do want it to look nice. Okay, before I go further, I'm just going to take a peek here. Who's joined us? Okay, so most people can hear. I see Lydia has no for the audio. If someone can maybe, just let her know. Okay, she is switching it to yes. I see Stephanie has joined us as well. Some others. Austin is here, but he fell asleep. Oh, no, I'm sorry. Austin is not here. Andrew is here. Okay, so some others might join us later, or maybe they'll watch the replay. So don't waste a lot of time simplifying derivatives. Okay, next up we have this is on the worksheet on the study guide, but there is going to be a bonus question. It's a good mathematical skill. In AP Calc, you're supposed to really practice thinking more like a mathematician. And one of those things that mathematicians do is prove things or give an argument that shows that something is true. So if you can derive or prove those following derivatives on the right, you might have a chance to earn some bonus credit. I wouldn't spend the bulk of your time studying it, but if you have some extra time and you can, practice the derivation on your own, that could earn you some bonus points. The thing is, we derived about 5 different rules, and I'm not telling you which ones are going to be on the extra credit. There will be 2. There will be 2 derivations on the extra credit. I'm not telling you which ones, but chance to earn points there if you have time to study. How should you study if you have not already? Practice, practice, practice. You have to actually do the problems. Don't just stare at them. Reproduce conceptual material from scratch. Also, this just means take out blank paper, take out notebook paper, see if you can write down some of this information. Definitions, really the key ones are, limits, continuous, differentiable. Can you give examples when things are continuous and not continuous? Can you give examples of things that are differentiable and not differentiable? And can you write out some procedures? How do you do implicit differentiation? When do you need the product rule? If you actually take the time and write out line by line some bullet points, you will remember those things better. Okay, so those are some tips I learned from Mr. Treitler, my calc teacher, and they kind of stuck with me. That being said, if you could, if you haven't already, you could start typing questions in the Google Doc. We're going to proceed. I told you it'd be a short presentation, so thank you for listening. And now it is time for your questions. Yeah, this picture I just kind of found on a Google Slides template that I used for this PowerPoint real quick. So I was like, it looks like there's a light at the end of the tunnel of chapter 4. So we'll go with that metaphor. And if you have any questions, you could start typing them in the Google Doc. I see we have one in red and some others listening. Hopefully you could start typing as well. And I'll try to get to your questions as quickly and efficiently as possible. I got 7:52 on the clock. We'll go to 8:15, but if you have more questions, I don't mind staying a few minutes extra. So let's take a look. We have question number 1. Okay, for number 1 on the study guide, let's actually, let's go to you so you can see a different view here. So we might use the sketch pad, and I'm going to go to this. Hello, Mr. Droza is here. This is my mathematical layer. I'm going to share with you my entire screen just so we can use the sketch pad to work on some things. Okay, that's not what we want. Here we are. So here's the Google Doc. I'm going to minimize this. And I had Sketchpad up, but okay, here's a Sketchpad I'm going to use if we need to draw or write down some information. And here's our Google Doc where your questions are. So the question was, for number 1 on the study guide, why did you use the differentiated equation to find the vertical tangent point, but the original equation to find the horizontal tangent point? Good question. Well, keep in mind, when you're finding the x values, you might have slightly misunderstood my work. But to answer this question, when you're finding the horizontal tangent and you're finding points of vertical tangency, you're going to be looking at the certain x values for the derivative. Okay, and horizontal tangent, what you're looking for there is when the derivative is equal to 0. In other words, when you have f prime equal to 0, you're going to have a horizontal tangent. So for that one, you solve for y prime equal to 0. And it really depends on a case-by-case basis. I'm just pulling up that one now. So my y prime here was negative 2x over, and just let me know if I don't answer your question, you can maybe rephrase or get at a different point. But this was the y prime we had for number 1, 4y cubed minus 2y. And if I want to know when this thing is equal to 0, okay, when is this function equal to 0? Well, a fraction or a rational function is only going to be equal to 0 when the numerator is equal to 0. And if you want to be extra cautious, you want to say when the numerator is equal to 0 and the denominator is not equal to 0. So there's really only one x value that's going to make this numerator equal to 0. So that's how I figured out horizontal tangents. And I figured out the x coordinate when the f prime or the derivative function is going to be equal to 0 is going to have to be 0. So I always am working with the derivative when I'm looking at the x values, in this case for horizontal tangent. Once I have that x value, to find the y value, well, then you want to go back to the original function, because remember, we're looking for the points of the original function that have a derivative of 0. That's going to be the horizontal tangent points. So to find this y coordinate for each of these, you're going to plug back into the original function. Okay, so hopefully that helps you a little bit. But let's continue on, though, and look at the vertical tangent. Okay, so let's keep this same up, and let's look at the vertical tangent. And please, keep asking if I don't hit upon your question, just let me know. But I think this is going to help you here. Let's talk about the vertical tangent, because that is going to be a little bit different. For vertical tangents, we're looking for where the derivative is undefined. in particular. And if you had a graphing calculator, you could graph it. There's no calculator tomorrow, but we're looking for where the function is undefined, and that's going to be now we're looking at the denominator. So when we're finding points of vertical tangency, we're going to look at this denominator, and we want to think, okay, the function's undefined when that denominator equals 0. So that's why I use the 4y cubed minus 2y, set that equal to 0, and I solve for a bunch of different y values. Those are the y values that make the derivative undefined. But then, since I'm looking for the ordered pairs where the derivative is undefined, I'm looking for the points where the derivative is undefined or has a vertical tangent on the original function. I have to take the y's that I solve for. I'm just looking at my sheet here. I'm doing a little cheat here. It was root 2 over 2 and negative root 2 over 2. So once I have those, then I have to go back to the original function. Okay, so the general process is use the derivative. Use the implicit derivative, the y prime, to locate where you're either having a horizontal tangent, where you're having a 0 slope, or where the slope is undefined. Once you locate one of the coordinates, in the first case we found the x's, in this case we actually found the y's. Once you locate those, then you go back to the original function, substitute for x or y, whatever is appropriate, in this case it will be y, and solve for the other variable. Okay, so that's actually a good question because it depends whether you're finding horizontal or vertical tangents, whether you're going to use the y's or the x's, but both processes involve using the original function as well as the derivative. Okay, so I hope that answers your question. I'm going to put C webinar. If you have another follow-up, please ask me based on that. Next up, we have a little question. Can you please find dy dx of y equals x to the tangent of x? Let's look at that together. I like this question. It's going to employ several derivative rules. So we're doing y equals x to the, we have in the exponent, tangent of x. Okay, let's be careful here. Let's list on the side the rules we're going to have to employ. And I'm just checking back. Hopefully you can all hear the recording. I see a lot of yeses. Okay, Julia has joined us. Elton has always been a yes. Manish, welcome. Hello, it's good to have you here. And we have some other yeses as well. Those of you who just joined us, feel free to type questions underneath, and I'll try to answer them as best as I can. Okay, so we're continuing the derivative of this function. I can see at least two rules that are going to be involved. First, if I did give this kind of question, I would assume that the x is greater than 0 and not equal to 1. Otherwise, we get not really a nice exponential function. So the rule we have for exponentials is dealing with those type of exponents. And it says d dx of a to the x is equal to the ln of a times a to the x. So that's the first appropriate rule we're going to use here. So I'm going to use y prime, and I'm going to assume these conditions about x. And we're going to say that that's equal to the ln of the base, or in this case x, times the original function, a to the x, or in other words, x to the tan x. But in this case, you notice, since we don't have just regular old x in the argument, trying to find some colors here. Colors. Where are they? Come on, give me some colors. One moment, please. Aha. Okay, some colors. Let's see if this works. Oh, you know what? I think I need colors. I need the pen. Oh, this thing is so annoying. No, I want colors. Colors. The lid. Head for the lid. The lid. The lid. Okay, I feel like Patrick here. I can't find the darn colors. Yeah, okay. I'll have to figure that out. But we're using the chain rule because this is not a regular x. If this was just x to the x, we wouldn't need chain rule here, where the derivative within would just be 1. But since we need to multiply by the derivative within, we multiply by the derivative of tangent of x, and that will be secant squared x. And this looks pretty simplified to me. There's no rational, no radicals we need to rationalize. There's no negative exponents, and there's no common factors to pull out. So that would be good enough for an answer tomorrow. Okay, so hopefully that helps. I'm going to put C webinar under this question. Thank you for who asked that question. And if you have another question, go ahead and start typing it in, and I would be happy to answer it. Meantime, let me just say this. This was one thing I forgot to say during the presentation. I said practice, practice, practice. If you're looking for good problems to practice, if you're like, okay, I practiced a bunch of stuff, but I don't know what else to do, the chapter 4 review in the textbook I found is actually very good. So I think you should look at, the review exercises start on page, let me just get this right. Yeah, 189 to 190. Look at the odd problems. I think I mentioned this on the Google Classroom announcement. But these, if you look at the odds, the answers are in the back, and it's just a good survey of some problems if you need more to practice to make sure that you can do them. Because I'm telling you, don't just stare at the problems. You have to pick out problems, particularly harder ones, and do them from start to finish. That's how you're going to know if you're ready for tomorrow. Okay, if you just stare at them, you're not going to be able to know if you are ready. But anyone else who brought questions, feel free to start typing them in. Let's see. Okay, we had a couple good questions to start. And for those of you who are joining us late, thank you for coming. And definitely feel free to type your questions in. Well, let's just see. Let's just do a little definition practice then, for those of you who are paying attention. An example you might want to know for tomorrow. Say I had some kind of piecewise function like that, and you want to be able to explain, and this could be in the context of a multiple choice question or a throwback question, open-ended, but is it continuous? Is it differentiable? Where are there issues, and why are there issues? So I'll just kind of phrase that as a question unless somebody else has a question, but kind of try to answer this on your own. Is it continuous? Let's say on the real numbers. Is it differentiable on the real numbers? If not, where are there issues? And why? Explain the issues that there are. Like, what part of the definition does it fail? What is going on there? How can we explain that in calculus terms? That's just something to think about as more people type questions. Can you answer that? Okay. So I'm going to type this in at number 3. We'll see, can you answer my question below? Feel free to type an explanation, and we'll highlight some good answers. And if anyone else has a question, you can just insert that in. Can you answer my question? And to repeat my question, based on the picture I'm showing of a graph, is it continuous on R, all real numbers? Is it differentiable on all real numbers? And if not, where are there issues for either of those? And what are the issues? Can you explain them using good terminology? We like our explanations to be concise and clear. Just go ahead and start typing a bullet point. Feel free to bounce ideas off each other. But the question again is continuous on all real numbers? Is it differentiable on all real numbers? Where are there issues? And can you explain those issues? Okay, we got a good answer there for the first part. It's continuous because it's continuous at every point on the interval. That would be sufficient. You can see it's fully connected. There's no holes or points of discontinuity. So that looks good. How about differentiable? How about differentiable? Also be careful there with just saying define. Remember, continuous means more than just defined on the interval. Just be careful. There are 3 conditions it has to meet, and that means more than just being defined. And I'm going to draw another example in a second where that will come into play. Okay, so we have an answer coming through for the second part. Is it differentiable? And it's not differentiable because there is a corner type thing. Okay, we are on the right track there. Just please, on the AP exam, you cannot write corner type thing. They will not accept it, and you'll get credit for saying the right answer, but you won't get the explanation point that we want you to be able to get. So someone else has added. Looks like Manish. There is a cusp. Okay, very good. And we can obviously, if there's values, we could specify if this is 1, 2, etc. And I'm guessing you're pointing out this cusp here at 1 or corner. You can refer to it as either one, which is why it's not differentiable. Technically, also, if you want to be really clear with your definitions, why is it not differentiable at a cusp? You can say something like, and this came up on a piecewise function on the last test, I think, the super packet. The derivative or the slope from the left does not equal the slope from the right. That's just a little more formal terminology, or you could say the derivative from the left doesn't equal the derivative from the right. In other words, we have a different slope here than here, and in order for the function to have a derivative at that point, remember this has to be true. The limit as h approaches 0, it's a two-sided limit. As you go to h from either side. And, oh, this is minus. We have our definition of a derivative. So that has to be true from both sides. So that would be another way to phrase that. Okay. Yeah, can you use sharp point? Good question. You know what? I'm going to get back to you on that. I would accept it. For my test, for my quiz for now, perfectly good explanation. I'll get back to you if the AP readers would accept that as a brief explanation. It's not differentiable at x equals 0 because there is a sharp point. You might have to be a little more formal. I have a feeling they would not. For me, that's good enough for now, but we will. I'll revisit that and talk about that. But folks, if you have other questions, I just kind of made up an example here. This time is for you to ask questions. I have 8:08 on the clock, so we definitely have at least another 7-8 minutes, and we can talk about those. But if you don't have a question, I can make up another one. But I'd definitely prefer to answer your questions that you have. So, okay, we have a couple more questions that have come up. Number 15 on page 189. Let's look at that one. Ooh, that looks like a fun one. That looks like a really fun one. 189. E to the, and by the way, you're all going to have to do the Khan Academy capstone eventually. I didn't assign it yet, don't worry. But it basically, it's all the derivative rules into one Khan Academy assignment. So it tests whether you can use all of them efficiently. And that's going to be a good practice. It's called the derivative capstone. It's pretty cool. I looked at some of their problems. But okay, I think we want the derivative of this. Find the derivative of the function. Yes, okay. Let's roll with it. So y prime would equal the e to the x is just itself, e to the 1 plus ln of x times the derivative within, which is the derivative within. Well, we have derivative of 1 is just 0, but we're going to be multiplying by this derivative, which is 1 over x. And okay, I see what they're going with here. So this is going to be able to be simplified further. It's not as obvious. I mean, if you just apply the straight up chain rule, this is what you're going to get. But whenever you see e to the and something with an ln, you want to think a little further. Usually you're going to be able to simplify quickly. So instead of this approach, I just applied the straight up chain rule. I'm going to look at this slightly differently. And I'm going to say, oh, I notice an e to the ln. And those are inverse operations. They're going to cancel each other out. So actually, let me rewrite this function. And this might have been why you asked the question, because the book answer comes out a lot nicer. And using exponent rules, we can rewrite this as e to the 1 times e to the ln of x. Okay, remember the, just good old-fashioned exponent rules. A to the n times a to the m equals a to the n plus m. So they're actually using that rule in reverse. And here's what you arrive at. And what is this equal to? Well, so this is a little tricky. This is e, and then e to the ln. Those are going to cancel each other out. Those are inverse operations. So that is actually just equal to x. So this function is really just e times x. And so this implies the derivative is just e is a constant. And so the derivative is just y prime equals e. Okay, so that was a little tricky. You had to use a rewrite of the original function to notice that. And the clue is if you see e and an ln there, or the reverse, if you see the ln of e to the something, that should be a clue. Those inverse operations are going to cancel each other out. This is just equal to 2x. E to the ln of anything is that thing. That's just a good property to know. E to the ln of anything is that thing. And the ln of e to the anything is that thing. Those cancel each other out. So you just get the argument or the expression inside. Okay, hopefully that was helpful to you. I'm going to put C webinar on that one, or C video. Okay, let's look at the next one. How would you do y double prime? Thank you for taking the time to type this question in. And we'll look at that. Y double prime of 2x minus 3, or sorry, 2x to the third minus 3y squared equals 8. 2x to the third minus 3y squared equals 8. I think that is what you wrote there. All right, and we got to do y double prime. Let's tackle this implicitly. So this will be 3 times 2x squared. Since we're differentiating with respect to x, we're not going to need a chain rule there. Minus, and I'll just do the 2 times 3y to the first times chain rule y prime equals 0. Whenever you have something, a function y, you're differentiating with respect to x, you need a chain rule there. So this is a y prime. This is a 1. Simplifying, we have 6x squared minus 6y y prime. Solving for y prime, we will get negative 6x squared over negative 6y. Or in other words, y prime is x squared over y. Okay, let's look at y double prime now. Because in order to have this correct, you got to get it in terms of x and y. You can't use y primes. So y double prime, and this is clearly a quotient rule. We have two functions here. So it's going to be bottom times derivative of top, just 2x, minus top times derivative of bottom. Derivative of y is y prime. That's where you're going to need that substitution later, over y squared. So that would be your answer. And then you would just need to substitute in for y prime what we arrived at previously. Substitute that in and then simplify the complex fraction. So we'd have 2xy minus, and then this will be x squared times x squared is x to the fourth over y, and then over y squared. You can't have a complex fraction in the final answer, so you just need to simplify this further. If you need me to do that for you, I can, but that's the gist of how you would set that up. Okay, feel free to ask follow-ups. I'm just going to say see video for that one. And we'll move on to another question. Yeah, I gotta learn how to use this better because there's a way to create a new page. Okay. All right, we are at 8:15, but I'll take a couple more questions if you have them. Not an issue, so thank you for the next one. At what point on y is the slope parallel to that? Okay, so we're looking for a point on this 3 to the x plus 1. When is that parallel to 5x minus 1? Well, we know, so we're basically asking when is y prime equal to 5, because the slope of that other thing is 5. So we have to find y prime and then solve for when it's equal to 5. Okay, so let's do that. Y prime, using the what we said before, is going to be ln of 3 times 3 to the x plus 1. We have no, it just becomes 0 when you differentiate term by term. And so we have to just set y prime equal to 5 and solve for x. Okay, yeah, it's going to be a little tricky here. Whenever you're solving for an x that's in an exponent, this is a good pre-calc algebra 2 skill, you are going to need logarithms. So there's no way around that. You're going to end up using some logarithms in order to get an exact answer. Otherwise, you can just have an approximate answer. So first, let's see, best way to go about this. You know, I'll isolate the 3 to the x. So we'll have 5, and then we'll have ln of 3 equals 3 to the x. Okay, and then I'm going to translate this into logarithmic form. In other words, so you know, I should probably write here just so you recall. If you have log base b of n equals x, this is if and only if. Okay, b to the x equals n. I'm going to use that note to translate this thing. I wish I had different colors. Sorry about that again. But if we translate that, we get log base 3 of this guy, and that is equal to x. So log base 3 of 5 over ln 3. Let's see if I can clean that up a little bit. But this is a messy looking answer. So there's definitely a way to clean that up better. I mean, it's accurate. X would be equal to log base 3 of 5 over the log of 3. So the question is there an easy way to clean that up? Well, I mean, you could split it up in 2 logarithms. You know, the log of a quotient. Yeah, that actually looks nicer. You shouldn't have a log within a log. So this would look a little bit nicer. Log base 3 of 5 minus log base 3 of ln of 3. You still got a log inside a log. So you'd have to work to clean this up. But the process is what's important there, of setting the derivative equal to 5 and then solving. I'm curious, is this a textbook problem? So I can see how the textbook left it. Oh, the textbook, yeah, that makes sense, Julia, that it was decimals. Okay, thank you. Yeah, because I'm trying to, yeah, algebraically, there's really, you're not going to get much nicer than that, but you can use a decimal, use a calculator, do log base 3, and you should arrive at your result. Okay. No problem. You're welcome. Thanks for clarifying. And I'll just leave it open if you have one more question. We are at 8:19. Hope this has been helpful to you, at least in maybe pointing you where to study. And those of us who could not join us, I am going to post the replay. Oh, I forgot to say. Did anyone notice the poll question? There's a little tab where you're supposed to click on a poll question. I should have put it on the sign-in. But on the YouTube video, I was trying something new. It's called like a button, or I forget what they call it. But I can actually put a poll, and you can all answer the poll live, and I can actually get the information from like this thing called the live control room. Anyway, and I can see your answer to the question. I forgot to tell you about that. You might have just closed it, thought it was a pop-up. But in the future, I will make use of that poll feature. But we'll just say, any more questions? Going once? Going twice? Going once, going twice. Okay, as a final thought, I'll just say, make sure you know your, for continuity, I asked that question before. know the three conditions for continuity, because that can be relevant, as well as when some things are differentiable or not differentiable. I mean, it's not going to be the whole test. The test is mostly on derivative. It's on taking derivatives, using different rules, and applying that accurately with tangent lines and such. But there will be some conceptual stuff, particularly multiple choice, where you'll need to know continuous and differentiable. So just keep that in mind. All right. Going once. Any more questions? Going twice. And sold. So we will close it out there. And thank you for all of us who joined. Hopefully this has been helpful to you. I'm Mr. Droza. Have a good night.